Hello, hello student of class 8. Once again, I am Sudhi, and today in my video I will show you the solution of the exercise 6.3, the other part. So the half of the questions I have done in the previous video. So this is the remaining part of the same exercise 6.3. Now, student, you see here in question number 6. The question number 6 is the just reverse of the question number 5. In the question number 5, it was asking to find out the number which can be multiplied, okay, so that the other number become a perfect square. Now here in question number 6 is to find out the whole number which will divide the number so that the number will become a perfect square. So in question number 5, it was asking you to find out the number to multiply. Now here it is asking to find out the number to divide. Okay. So it is a little reverse of the question number 5 only. So, but the process is same. How we find out the number, that process is same. Okay, clear. So let us see. So first of all, what we have to do? We have to do the prime factorization of the number here. The number here, let's see, 1, 2, 1, 4, 6. 6 questions are there, 3 I'm doing here. So you see, first of all, we have to take the prime factorization of this number. So what is the question asking? Let's try to understand together. Find the smallest whole number by which it should be divided so as to get a perfect square. We have to find out a whole number. We have to find out a number that will divide this number so that this number become a perfect square. That means the number given in the questions are not perfect square. So they must make a perfect square by dividing by a number. So what is that number we are going to find out? How we can find out is the same process that we find out how we find out in question number 5 what is to multiply. Here is what to be divided. Okay. So let us see. So let us take the prime factorization of this number here. So 2, 5, 2 we are factorizing. So 2, 1, 2 and here 6. Then we got here 2, 6 and 3. Now here 3, 2, 1 and 3, 7. So the prime factorization of this number is so we can rewrite the number as the product of prime numbers, isn't it? That is 2 into 2 into 3 into 3 into 7. So for taking the square for taking the square root of this number, we have to pair two numbers, isn't it? Of same time or same kind, isn't it? 2 and 2 or 3 and 2. But here you can see that one number is unpaired now. So this number 7, this is the 7 number. The question in 5 also having the same number. In the one number 1 here also having 1. So yes, we got this 7 as a number which is unpaired. We have this 7 as unpaired here. So this unpaired 7 is the number. If you divide this number, then you will get a perfect square. Okay. So we have to divide this number by 7. So that unpaired number we take and divide the number and see. Then you will get another number which is a perfect square. So divide this by 7. For example, okay, that is 2, 5, 2 will divide by 7. We'll divide by 7. So 2, 5, 2 will divide by 7. How much we can here? You see, let us divide here once more. Okay, 2, 5, 2. These things are not necessary to show, but we have to find out the number. Which is number to be divided. So here the number is 7. That's all. Okay, but I want to show you that. Means let us check together. So 7, 3, 21. Then we get here 4, 42. And 7, 6 are 42. 36. Now we get here 36. So 36 is 6 square. Isn't it? 6 square. So this becomes a perfect square now. 36 is becoming a perfect square. So if we divide this number given here by 7, here where we get the 7, from where we get the 7 is that from the prime factorization. When we pair the numbers, we get one number unpaired. The unpaired number is to be divided number, so that number becomes perfect square. Understand? We can check here. So we are dividing this number by 7, so we get a 36. So 36, 36 is the perfect square. 6 is the 36. 6 is the 36. Isn't it? So 6 is the 36, so it becomes a perfect square. Like this, we have to find out the number to divide this another number here into one number 3. So let us take the prime factorization of this. 396, just there's 2, 1, here 9, 18, 2 is 16, and here 2, 9 again, 2, 9, 99. Now 2 cannot be 3, 3, 3, and here 3, 11. So 396. Now we are writing as the product of its 5 factors. This 3 into 11. So these two can be paired and unpaired. One unpaired number is there, isn't it? So 11. So 11 is the number, so that you divide the number by 11, then you will get a perfect square. Once again, you see here, if we divide 396 divided by 11, okay, then how much we can here, you see? For example, 396 divided by 11, isn't it? 11 3s are 33, 6 the 66, isn't it? Yes. So again, we got here 66. So 66, 36, no 66. We got here 36. So 36 again, 6 square. We get a perfect square, 36, isn't it? So like this. Same way, here also you see, here also take the prime factor of this number 1620 prime factors. So yeah, 2, 2, 8, 2, 1, 0. Yes. Then we come here 2 again, 2, 4 is 8, 2, 5 is 8, isn't it? No. We just read 1 cannot be shown, 0 here. Then 2 cannot be. So 3. 3, 1 is 3, isn't it? 3, 1 is 3, then you know 3, 3 is 9, and 3, 5 is 15. Here 4, 5, 9, yes. 3, 3, 4 is 12, 3, 5 is 15. Here again 3. 3, 1 is 3, and 3, 5 is 15. Here, then again 3, 5 is 15. So now you see here, we can rewrite this 1620 as the total of this prime number 2 into 3 into 3 into 3 into 5. Now these two, you can hear these two can be paired, but unpaired numbers are there. Two are the unpaired numbers. These are the unpaired numbers, isn't it? They are unpaired numbers. So if you divide by those unpaired numbers, this the number given here, then it can be a perfect square. So let us see what is the number. Now we can here, if we divide, therefore the required number to divide, the required number to divide is 3 into 5, it is equal to 15. So 15 is the number. So if you divide this number by 15, then you will get the square. That's all. Okay, clear? So that is all. So here I'm just giving you some more tips here to understand how they become the perfect square, but not necessarily this to be solved. Just write that like this, and you know that the unpaired numbers have to be divided. So 3 and 5 are there, so both have to be divided. So 3 and 5, 15, isn't it? 3 into 5, 15. So 15, if you divide this number by 15, then you get the number as perfect square. Okay, so this is what we have to do. Okay, so the other question, please you try yourself, then we will come again to the next question. There's only one thing here, I just missed one more number here. You see it? Yeah. See, 1, 2, 3, 4. 1, 2, 3. I'm taking 3, so we have to take 4 here. This 4 3s are here. That means this also can be here, isn't it? That means only 5 is there. Only 5 is there unpaired. Sorry, they are all together 4 I was taking 3 only. So they are all together 4 trees are there, that means we can pair 2 to, isn't it? Then only 5 is there unpaired. So that means 5. Okay, not 15. Not 15, not 15 because I was taking 3 trees. There are 4 trees are there, isn't it? 4 trees means 2 can be paired and no more 3 again. So there is only one number, that is 5, which is unpaired. So this unpaired number 5 is to be divided this number, and you will get the number as the perfect number. Okay, sorry, perfect square. That's all. Okay. So let us go to the next question. Okay, my dear student, here you see question number 7. Question number 7 is telling that the student of class 8 denoted rupees 2,401 in all in the Prime Minister Relief Fund. But one condition is given here that the student of the class 8, okay, how many students are there in the class 8? That must have number. Okay, how much the number of the student, that must the amount is denoted by each of the student. Once again, how much the number of students in the class, that must amount of rupees for every, or for each of them has denoted the money in the class, and altogether 2,401. Once again, how many number of students you see here, the amount of each student donated, each student donated as many rupees as the number of students in the class. Find the number of students. See, we don't know the number of students, but let us take the number of students as x, then the amount also will be x. Means how many the number of students. Okay, that will be the amount for every single child to be donated. Means the money which is denoted by, the amount which is denoted by a single child is same as the number of student in the class. Suppose in the class, it is 35 are there, so every student had to be donated 35 rupees. This is the meaning what is given here in the question. Okay, clear? So we don't know the number of the student. That is, we don't know the number of the student which is equal to the amount of the donation, isn't it, of one child or one student, isn't it? So let us take this number of student as x. Then amount will also be x. Got it? Yes. So let us see. So let x be the number of students, then in this year rupees, yeah, one thing implies that number of students x, number of students is x, isn't it? How many number of students in the class is x, we don't know. So that means how much they have multiplied, how much they have contributed or donated will be multiplied with one student. Isn't it? One student is donated 30. If one student is denoted 30, then we have to multiply with x, number of students. Yes or no, isn't it? And we will equal to this is 2401. Yes or no? Yes. But this amount also we don't know. Why? Because we don't know the number of students. The number of students x. So that's why number of students x will be multiplied with the amount of single person, isn't it? Amount of single person will be the number of student again, that is x. Rupees x, you can say, isn't it? Rupees x. So let us see once more again. If it is 30 rupees, then 30 rupees have to be multiplied with the number of students, isn't it? Then this amount will be getting here. So, but we don't know this amount also, because this amount is saying that the amount will be same as the number of students in the class, that means rupees x will be. Yes or no? Yes, like this. So like this, I am giving you here that rupees x multiplied with x. Okay, this will be equal to the sum rupees 2401 altogether, isn't it? Rupees x into x. Rupees x into number of student x, and rupees will be also equal to the number of student x, isn't it? Yes. Rupees x. Rupees x is amount for one side. How many children are there? How many children are there? X children are there in the class. That means rupees x into x. Okay. So it means that rupees x square equal to rupees 2401. That means these two can cancel. Remove this. Now we can get x square equal to 2401, and we can here x is equal to square root of 2401. See, here we get what we get here to do is that we are now supposed to take the square root of the number as per the condition of the question. The question is telling us that the amount of one student is equal to the number of the student in the class. Means that something square will be coming out. Something we have to take the square of the number. Yes. If you take the square of this number, you will get the number of the student as well as the amount. Isn't it? Because amount and the number of students are same. Isn't it? When amount and number of students are same, then we have to take the square root of the given number here, given amount of number here. So we have to take the square root of the number, isn't it? Yes. So here you see, we take the square root of the number, then we get the number of students. Also, as well as the amount of one student, isn't it? So let us see how much we get here. So how will we get the square root here? You know that by prime factorization. Let us do 2, 4, 2, 6, 7. Yes, we have that. Yes. So this type of question, please try to understand that the question is given condition that is student donated as many rupees as number of number of students as many as the number of this element. If these conditions are there, you must always remember that we have to take the square root of it. So we are going to take the square root of this. How will we take the square root is by prime factorization. Yes. So 2 cannot be 3, cannot be 5, cannot be. Now let's go to 7. Take 7, 7 3 is 21, isn't it? Yes. Then 3 can in hand, 7 4s are 28, 2 in hand, 21. Yeah, we can here 3 4 3, isn't it? Next 7. Yeah. Now 7 again here 7 4s are 28. 7 4s are 28, and here 63. 7 9 is 63. Then 7 7. So when we come here prime number, we can stop the division. Otherwise, you can take once more also. When you get 1, you stop. Two conditions are there. When you get the prime number, you can stop, or you can make it again as 1. Okay, by taking the number is. So here you see these two and these two can be paired. So we can get the square root of this. Again, that means x is equal to square root over 7 into 7 into 7 into 7. So these two in pairs, isn't it? Then we know that 7 square will be coming here, then square and the root will be cancelled, and we get here only x is equal to 7 into 7. Isn't it? That means 49. 7 7 is 49. So 49 number of students are there in the class, and each of them are contributing 49 rupees and getting this amount. Okay, to donate in the Prime Minister Relief Fund. It's written there in the question. Check the question. I'm just making to solve. Okay. So this is the answer. So therefore, how many students are there? Therefore, the total number of students in the class is 49. That's all. Okay, that's all. So my dear student, with this question, I would like to tell you that question number 8 you also have the same condition. So please do that question number 8 for yourself. Now let us go to the next question, question number 9. Okay. So once again, student, here we have question number 9 and question number 9. You see that conditions are given here. Find the smallest square number. Find the smallest, find the smallest, find the smallest square number that will be divisible by these three numbers, by 4, by 9, by 10. Means we have to find out the smallest common multiples of this 3. Smallest common multiples of 3. You got it? So if we get the smallest common multiples of these 3, then that will be the number. That will be the number that can be divided by 4. So you just remember that number that can be divided by some 2, 3 number means is a common multiples of the number, isn't it? So the common multiple number is the only that can be divided by these 3. So that common multiple number, that number which is common multiple, that is LCM. We have to take the LCM of this 3 number. So that LCM is a perfect square or not. We have to check it. After taking the LCM, we have to check that whether the LCM of this 3 number is perfect square or not. If it's not perfect square, then we have to go back to question number 5 or 6, and we have to apply that theory again. I mean that idea again. If it's not perfect square, how you can make a perfect square? That is the logic one. Okay, once again, in this question, in this type of question, in the beginning, I want to tell you that question number 9, I will show you question number 10 is yours because same condition only different numbers. Okay, clear? Once again, the condition of the question is that find the smallest square number that is divisible by each of the number 4, 9, and 10. That means the common multiples of these 3 numbers can be divided by this number, isn't it? Yes. That means we are going to find out the LCM of these 3. First, we will find out the LCM of these 3 numbers. If the LCM is a perfect square, then that will be the smallest square number. LCM, lowest common multiples, smallest square. The LCM must be perfect square. Okay, it should be a perfect square. Means many LCMs are there. Okay, many LCMs will be there. They can divide by just 3 number again and again. But whatever, we have to find out the number that LCM or the common multiples of this 3 that is square, perfect square, and that should be the smallest one. So the LCM may not be the square, but we have to make it a square, isn't it? How we make the number a square, then we have done in question number 5, isn't it? So like it we have to do. So let us take the LCM of these 3 numbers now. Okay, now then we are going to take the LCM of this number. Let us see. We'll take the LCM of this number and we'll have to check whether the LCM is a perfect square or not. If it's not perfect square, then we have to make a perfect square. How we make a perfect square, we know that, isn't it? So let us take the LCM of this number now. 2 to the 4, 9, we cannot do anything. Then 2 by the 10, we can get 1, 2 is there, 2, 1 is 2. Then 9, we cannot do anything, 5 also we cannot do anything. Then we'll take 3 here, 1 is this, and 2 is 9, 5 we cannot do anything. Now here again, 3. 3, 1, and 3, 1, and 5. So here we can take 5 and all are becoming 1, 1, 1. Then we finish here the division. So the LCM, how much the LCM will be here? So let us see. Therefore, again, let us start the solution. We already start the solution, isn't it? Yes. The solution you see here. Now we have to take the LCM of this number, isn't it? Yes. The LCM of the numbers is, that is 2 into 2 into 3 into 3 into 5. Yes. 2 to the 4, 3 to the 9. Great. 2 yeah. 2 to the 4, 3 to the 9. That means 4 into 9 into 5. That means how much will be here? 4 9 36. 36 into 5. Then how much will be here? Just the 33 yeah, 15, 18. Yes, we get here 180. We get here 180 as the LCM. Now 180 is the LCM. Let us see it is the lowest square number or not. We have to find out whether this is a square number or not. 180 is a square number or not. We are going to find out. So by finding out this 180 is a square number or not, then we can find we'll get the answer. If it is a square number, then this is the number that can be divisible by all of this and also some of this. But it is a square number or not, we have to check. How we can check this? That is, we'll take here. That is, okay, 180. 180 is equal to, you can write down that here 182. Again, by factorization, isn't it? Square. So the square of what? So, yeah, 9, 0, 2, 4, 5, and here 3, 1, 5, and 3, 5. Now you see here, 2 into 2 into 3 into 3 into 5. Now, you see here the prime factor of 180, which is the LCM, the prime factor of the LCM 180. See, it is 2 into 2 into 3 into 3 into 5. So, 2 and 2 they can pair, 3 and 3 also pair, but here one number is unpaired. That means 80 is not a perfect square now. We have to find out the perfect square. Not this 80. 80 is not the answer. Okay. Yes, 80 is the LCM, but it's not the perfect square. So this is not the answer. We have to find out which is a perfect square and also common multiple of these three numbers. That means, so 80 into 5 equal to, take this 80 and take this one more 5 here to make it square. To make it square, this 180, we have to take one more 5 in this, we have to multiply with 5. If we take one more 5 here, isn't it? Then that means we have to multiply with 5 to this 180. That's all. So we multiply here 180 by 5. Then how much we get here? That is it. 5 0 0, 5 8 is 40, 1 again 44 and 9, isn't it? And 5 1 90. So 90 then 900. 900 is the smallest square number that can be divisible by all these three numbers 4 9 10. Here is the answer. We get here 900 as the answer, isn't it? So therefore 900 is the smallest square number divisible. So 900 is the smallest square number that is required. We got it, isn't it? Yes. So that is we find out the answer for this question in the given condition. For question number 10 also, having the same condition. Question number 10, I am just doing it for you. Please do it as your homework or your working on. Okay. Put yourself in practice to do these things. Okay. So for today, I want to conclude my video session here. So we'll meet again in the next video. Till then, have a nice day all of you. Thank you once again for watching my video.